Hey guys, how's it going? My name is Gabe, and this is Games with Gabe, and this is the next episode of the Coding a 2D Game Engine in Java series. In the last episode, we got to this point where we have jumping working, we can spawn power-ups, and we can spawn flowers, and we can power Mario up appropriately and everything, and it all works good. And then the mushroom has some basic AI so that if it hits a block, it just sort of turns around and continues moving along. In this episode, what we're going to be doing is implementing the Goombas and possibly the turtles and changing the background color of the camera. So let's see how much of this we can get done. First thing I'd like to do is let's go into our scene, and we're going to do a couple things. Not the scene initializer, but the level editor initializer, or whatever it's called. So I want to do a couple of things. First of all, when we open up our menu, we have all of the blocks here, but this is kind of stupid because first of all, I don't want to place a block like that and be able to run into it. Like these all have default bounding boxes and stuff. And also there are some blocks missing that we could be using, but we're not because I stopped before we got to like all the decoration blocks. So, and then for instance too, this is a decoration block. You shouldn't be able to collide with this, but it gets a default collider added to it anyways. So basically what I want to do is I just want to add in a way to not add decorated blocks as like collision blocks, and then add a new tab up here that's basically just decorations. So we're going to do all that, and then we're going to add a Goomba to the prefabs after we get that done. So first of all, let's change this from blocks to solid blocks. And it's going to get a little crazy in here because I basically just hard-coded in when to stop, when to go. And I think we have this correct. This all looks good to me. Okay, yeah, that all looks good to me. So we'll just simply go down here, and then we'll say if imGUI.begin tab item decorations or decoration blocks. We'll do this, and then we'll just say imGUI.end tab item, just so that we don't forget to do that. And then we'll add in all the decoration blocks into here. Now to do that, I am literally just going to copy this because it's going to be very similar. So we'll copy all of that, and then we'll just paste it right here, and we might have nope, okay, that's good. Cool. And technically you could extract all this into like a separate function, which would probably be cleaner than what I'm doing. So if you want to write some better code than me, I would suggest doing that. Now, instead of going from 0, we're going to start from 34 because that's when all the decoration blocks start. And we're just going to stop at 61, which is when the decoration blocks stop. And then right here, we're going to say if I is greater than or equal to 35 and I is less than 38. We want to skip all of those blocks. And then we also want to say if I is greater than or equal to 42 and I is less than 45, skip all of those blocks too, because those are all just solid blocks. So we don't want to duplicate them into the this area. Okay, and then when we go ahead and push the ID, we can get rid of a lot of this because we're not going to have these be physics objects, so we don't need the rigid body. We can get rid of that. We don't need a box collider, so we can get rid of that. And these are not ground, so we can get rid of that. And there are no breakable bricks, so we can get rid of that. So we should just be left with those two things, and that should be good. So if we go back in, we should have a new tab, which is decoration blocks, and then we can go ahead and add stuff from this tab. And so if I just add a few of those, and then I'm actually going to delete that, then we should be able to run right through this. And sure enough, we can run right through that. Cool. So that's going to be nice just for the future when we go ahead and actually implement decorations if you want to. If you don't want to, you know, do whatever you want. This is your engine. This is just a tutorial to teach you how to do what I did. So you can change it however you want. Anyways, we're going to have to add a new prefab. So we have generate Mario right here, then we have generate question block, and I would like to say, let's create a generate Goomba. So basically we're just going to sort of copy this stuff. I think that's going to be pretty good. So we'll just copy all of that. We want to make sure we do it on the same line because this is just the third thing we're adding here, so we shouldn't be overrunning the line width or anything like that. Let's also go ahead and say imGUI.pop ID. That way we get rid of the ID that we had pushed for this guy, and we didn't actually push an ID for that guy. So this is important because we're going to be using some of the same textures again. So let's go ahead and we're just going to say imGUI.pushID here, UID++, and then we're going to say imGUI.popID. And it looks like we didn't do this at all actually. So we're basically just going to create a UID or a unique ID, which will be used just to make sure that if we use two images from the same texture, we don't like end up linking that to the same button, right? So we just sort of create a fake ID for imGUI for this tab, and then we just assign a unique ID for each of these things. And if we do UID++, that means that it changes every time we use it. So we can simply do that, and then right here, we're gonna say imgui.pushID UID++. Once again, it'll change the ID. And then right here, we'll also say imgui.pushID UID++. I feel like we use this in one of the above parts of this giant function. I just can't remember for sure. So then the Goomba, we do not need to get a new sprite sheet because he has his sprite inside of the player sprites. And so we'll just say his sprite is playersprites.getSprite14, which should give us the Goomba. So that's the texture ID. All of that stuff should be fine. And I believe the rest of this should be good, except we just want to change this to generate Goomba, which should give us a Goomba once all is said and done. So let's go into prefabs now. And inside of prefabs, I'm going to go ahead and copy. Let's copy block coin because I feel like this is going to be pretty similar to what we'll need, and we'll change it appropriately. So I'll copy that, and then I'm going to call this generate Goomba. And for now, it's just going to generate a block coin, which is fine because I just need to make sure it's working. So if we click into prefabs, no, it's not working. See, this is why we test things. It says size of stack, window ID stack. We missed a push or pop ID. So it looks like I missed it. I thought I was being careful, but not careful enough. Let's see what I missed. So we have imgui end tab item here. Oh, and I see what the problem is. I never popped this ID. Always pop your IDs. Okay. So with that done, we should be good. And if we just click onto prefabs, okay, cool. So we see the Goomba pop up. It's not, yeah, you see it played a coin noise and we actually got a coin. That's kind of cool actually, but that's not the behavior we want. We want to actually generate a Goomba. So let's go ahead and implement that so that it actually works. Let's go back into prefabs and we're going to change this to be the, we'll just call it sprites. It's the player sprites and the enemy sprites. And then we'll just change this to be spritesheet.png. Then we're going to call this Goomba because this is not a coin, and we're going to be getting sprite 14 for this Goomba, and the default size 0.25 is good with me. So the Goomba has two animation states, right? He has the walk and the squashed animation. So I'm just going to change this, and we're going to call this walk. It doesn't need anything special. 0.23f was good for me, and then from this we just have 2 frames. So I'll just copy that, paste it over that, and then we'll get rid of that. And we just want frame 14 and frame 15, and they both are going to use the default frame time. Cool. So that should be our walk animation done. And then we have one more animation, of course, which is going to be our squashed animation. Just set that to a new animation state. We'll say squashed title equals squashed. And then we'll say squash.add frame player, or actually just sprites, .get sprite 16. And we're just going to give that 0.1f. And we're going to say that this does not loop. Okay, cool. So those are the 2 animations, and we just have one transition because this is a very simple state machine. So we will say add the walk animation, and we also want to add the squashed animation to our state machine. And once we have both of those, we can set the default state to walk. And we'll say state machine.add state, or technically trigger. This function should really be renamed. So we'll say state from walk.title to squash.title on squash me, which is the trigger. And then we'll just say Goomba.add component state machine. And yeah, we don't really want any of these because Goomba is not a question block. But we do need a couple other things. The Goomba is going to have a rigid body because, of course, he needs to move. So we'll say rigid body 2D RB equals a new rigid body 2D. And we'll say rb.set body type to body type dot dynamic. So we're going to do something similar to Mario that with the Goomba. We can set the mass and everything, but I don't think this is going to affect it for real this time. So we should be good. I'm going to set the fixed rotation to true. And then we're going to say Goomba.add component RB. And then we're going to say circle collider circle equals a new circle collider. So we're going to do sort of similar to what we did with the flower and the mushroom. And then we're going to say circle.setRadius 0.12f and Goomba.add component circle. and then we're just going to return that Goomba. Cool. So we also need one more thing, which I almost forgot about. The most important thing, which is his AI. So we'll say add a new Goomba AI, which we don't have yet. So we will go ahead and create that very quickly. Call that Goomba AI. This extends component. And for now, he's going to do nothing. Oh, and that should be new Goomba AI. Okay, cool. So with that all in place, we should be able to just spawn in a Goomba and he should just sort of waddle. Yeah, there we go. So he waddles, but he doesn't really do anything. And if we were to hit play, he has no logic associated with him because we didn't actually implement any sort of AI yet. So let's go ahead and delete that guy for now. And let's go into Goomba AI and actually implement some logic. Okay, so right now I am going to extract a little bit from our Mario player controller. So I'm kind of going off script here from what I did in my original code so that this is just a little bit nicer. Let's go into Jade and we'll go into Physics 2D, and then let's just go straight into Physics 2D. And we're going to add a static function here. I guess it could be non-static. It doesn't really matter too much, but we'll make this static. And we're going to call this public static void. I guess this should return a bool though. Boolean check on ground. And this is going to take in a float inner player width and a float height. Okay, and we possibly need to add a game object in there too. Basically what we're going to do is if we go into Mario, or I guess player controller, he has this function called check on ground, and we just want to extract all of this logic because we're going to be using it in a few different things. So let's extract all that, and then we're going to put it inside of Physics 2D. So we'll just paste it here. So we do need a game object. We'll just pass in a game object as well, and we'll just call it game object. So this function takes in a game object, the player width, and the height. So we'll just change this to game object. We will get rid of this because we are now taking that as a parameter. And we'll set yval equal to whatever height they're using. Okay, and then we can set all of these a little bit differently. So yes, we can actually inline this. So I'm just going to say inline, and IntelliJ will automatically replace that for me, which is good. And then we'll just say instead of on ground equals this, we can just say return this. And now we have extracted that logic, which is good because now we can use it in several different things without having to worry. So if we go back into Mario or player controller, we should be able to change this up a bit. I'm gonna, and actually let's keep these inside of Physics 2D just so that we can actually draw things and debug and make sure that everything is going correctly. So I'm gonna leave this as it is, and then we'll just hit Alt Enter, import that, Alt Enter on Vector 3F, import that, and then we'll go back into player controller once again. And let's change this up to use this new function. So we will still need inner player width, so I'm going to keep that. We can get rid of that. We can get rid of that. We still need yval, and then we should be able to get rid of everything else. And then we can just say, instead of all of that, on ground equals physics 2D dot check on ground. We'll change it. We'll give it this game object. So I guess we should call this dot game object just so that's clear. For the inner player width, we'll just pass that. And for the height, we'll just pass y value. Okay, cool. So if we do this, we have just extracted that logic out, and we should still be able to play. You can see that, and you can see it shooting the raycast in the appropriate location. That's all good. Cool. So now we can go into our Goomba, and we can give him a similar functionality. So he will also have a public void check on ground function, which does something similar. And he'll have an inner player width, which equals 0.25f times 0.7f. So I just kind of tweaked values until I got something I liked, and that was what I liked. And then we'll say float yval equals negative 0.14f. And then we'll just say on ground equals physics 2D dot check on ground, this dot game object, inner player width, and yval. Cool. And of course, he's going to need a private Boolean on ground variable, which is false initially. Yeah, I'll leave that as false initially. And let's also make this transient. We don't want to serialize any of this data. Then he's also going to have a private transient going right, which is a Boolean, which is going to be false initially. So he's always going to start off going left. We could tweak that if we want to. We'll have a rigid body RB. We will also have a float walk speed. We'll have a private transient vector 2f velocity. So we're going to be sort of implementing these velocity things and everything ourselves again. And we could extract all this logic because it's going to be following our Mario player controller very closely, but you can do that on your own if you want to make your code just a little bit better. So then we'll also have acceleration and we'll have terminal velocity. And we've got that on ground variable. And then we'll have private transient boolean is dead, which is false initially. We'll have transient float time to kill equals 0.5f. So that's how long when he goes into a squashed animation state that will wait. And then we'll just have a reference to his state machine. And we'll just call that state machine. Cool. So we want to get references real quickly. So we'll say public void start, get a reference to the state machine, which we can do just by saying get component state machine dot class. Then we can say rigid body equals game object dot get component rigid body class. And then we'll just set the acceleration.y equal to window.get physics dot get gravity dot y times 0.7f. Same as Mario's. We should probably create a constant for that too, but like I said, I don't really care too much about this stuff. So we'll leave it as it is. And then we'll have a public void update float delta time. And one thing I did do is if the Goomba is to the right of the camera, I don't update it so that he doesn't start walking until we run into him. So we're going to get the camera real quick. We'll say camera equals window.get scene.get camera. Or I think it's just called .camera. And we'll go ahead and import that. Then we'll say if this .gameObject.transform.position.x is greater than camera.position.x plus camera.projection size.x times camera.getZoom, which that should give us basically like the width to the right edge of the screen in world units. So that's good. Then we'll just say return. Okay, so basically if the camera's to the right of us, we're not going to update this Goomba. He's just going to do nothing. Okay, and then we're going to say if we're going right, then velocity.x equals walk speed. Else velocity.x equals negative walk speed, right? That's pretty straightforward, self-explanatory. Then we'll just check if we're on the ground. Then we'll say if we're on the ground, this.acceleration.y equals 0. This.velocity.y equals 0. We don't want to be moving vertically if we are on the ground, so we'll just reset those. Otherwise, this.acceleration.y equals window.getPhysics.getGravity.y times 0.7. So 70% of box 2D's gravity. Then we can say this.velocity.y plus equals this.acceleration.y times dt. This.velocity.y equals math.max, math.min, this.velocity.y, terminal velocity.y, and negative terminal velocity.y. Okay, so that's very similar to what we did in player controller. We're just kind of clamping the y velocity to terminal velocity. We don't have to worry about the horizontal because we're setting that manually. And then we can just say set the velocity in the rigid body to our velocity. Cool, so that should be good. Except we have a problem because the Goomba is just going to move left, right? If we were to run this right now, and we just plop a Goomba down into here, technically he should move left. Something must be going wrong, so let's see what's happening. And I just did some simple debugging. He's not moving because what is walk speed? Well, walk speed is nothing. Yeah, it would be smart of me to actually initialize that before we try to use it. So what should walk speed be? Well, it should be 0.6f. That's the one that I came to and I liked. Okay, so now if we run this, there we go. So our Goomba dutifully goes towards Mario to try and kill him. Unfortunately, he's just going to hit Mario and nothing's going to happen because we don't have anything else programmed in. He's just going to push Mario along. So let's go ahead and make it so that, first of all, if the Goomba hits a block, he turns around. And then second of all, if he hits Mario, he kills Mario. So we'll go ahead and override our begin collision method. So we'll say public void begin collision game object, obj, contact, and vector 2f, contact normal. We'll say if we're dead, return. So if we're dead, we don't want to really do anything. Let's import that. And then we'll say player controller equals obj.getComponent player controller.class. If the player controller is not null, so meaning we hit the player, then what do we want to do? Well, we want to say if the player controller is dead. So if the player controller is not dead, and that is not a function, so let's go into player controller very quickly and just create a function that just says public boolean is dead, return this dot is dead. Okay, you go back into the Goomba. So if the player controller is not dead and the player controller is not hurt invincible. Okay, so this is a function we'll create, which is basically the player controller is sort of like in that phase where he just got hit by somebody. So he's invincible for a certain amount of time, or he's just invincible. That's what that checks. And the contact normal dot y is greater than 0.58f, which means, and that should be contact normal. So what is this saying? Okay, this is saying if the player is not dead and the player is not invincible for any reason, and the contact normal is greater than 0.58 in the y direction, which means the player jumped on top of the Goomba's head. That's what this means. And then we'll say player controller.enemy bounce, which will be a function we implement in a second. And then we'll say stomp, which is another function we'll implement in a second. And do we actually have enemy bounce? No, that's just, okay. Yeah, that's poorly named on my part. I named functions the same thing as I named the variables, which isn't very good practice. But we'll just comment these out for now. But basically, this is just going to execute whenever our Goomba gets stomped on. Otherwise, if the player controller is not dead and the player controller is invincible, which is something else we'll check for. So if the player controller is not dead and he's not invincible and he hit us, the only alternative is that he hit us with like a contact normal less than this, because otherwise we would have entered in here. Then we'll just say player controller.die, which is another function we will implement in a second. So if we hit the player controller on the sides, we kill him. And then we'll say otherwise if we are not hitting the player controller, if the math.absolute value of the contact normal.y is less than 0.1f, meaning we hit something on the side, then we'll say going right equals contact normal dot x is less than 0. Okay, cool. So let's go ahead and implement is hurt invincible and is invincible very quickly in the player controller. So if we scroll all the way down, we can go ahead and just say public boolean is hurt invincible, which will just say return this dot player state, or I'm sorry, return this dot is hurt invincibility time left, and that's a big word. I don't know if I spelled that right. I think I did. Is greater than 0. So this is a variable we will go ahead and implement. Just hit Alt Enter, and then we'll say create field inside of player controller, and this is just gonna be an int, and we're gonna initialize that to 0 for now. So I'll go ahead and move that down here somewhere. We'll just move it here, and we'll make this transient. So if they are hurt invincible, then, you know, we'll check that. And then for public boolean is invincible, this will just return this dot player state equals player state dot invincible, or this dot hurt invincibility time left is greater than 0. Okay, so that will just check and see if either of those are true. Cool. So if we go back into Goomba, we have no problems there anymore. If we run this, our Goomba should turn around once he hits a block. If he hits us, it's not going to do anything because technically we should die, but we don't have that implemented yet, so he just kind of pushes us. But if we go ahead and place a block there and he hits the block, he should hit it and start walking back and forth. Cool. So that is Goomba AI, almost done. Let's go ahead and implement these extra methods, which is enemy bounce, and stomp. We'll do those first, and then we'll do the player controller.die. So player controller.enemy bounce is actually going to be pretty simple. If we just go into here, we can say public void enemy bounce, and this is just going to say this dot enemy bounce equals 8. And I don't believe we use that in our jump physics. No, we did not. So if you just scroll up to where we are doing our jump physics for the player controller, we're gonna have to change it up a bit to incorporate enemy bounces. This is fairly simple. So we just check and see if the player is pressing the bounce key. We do all that stuff if we are. Otherwise, if enemy bounce is greater than 0, which means he is bouncing for a different reason, fix that very quickly. Then we'll say enemy bounce minus minus this dot velocity dot y equals enemy bounce over 2.2f times jump boost. All right, so it's literally just these two lines except applied to enemy bounces. So that'll give us a little bit of a hop so that when we jump on the Goomba, our player just sort of bounces a very little bit, and it's predictable. It should be the same every time we hit the Goomba, which is good. Okay, and for the stomp function, we'll just go down here and we'll say public void stomp with no parameters, and then this is going to call an extra function, so we're just going to overload a method, and this is going to say boolean play sound. I'm not sure why I overloaded this, but we'll probably find out in the future. But anyways, this is just a way in Java to overload a method with some default values, so that if you call it with no parameters, it just calls this with true by default. So we'll say this dot is dead is true. We're clearly dead now. This dot velocity dot 0, so we zero out our velocity. This dot rb dot set velocity to a new vector f. So we zero out our rigid body's velocity too. This dot rb dot set angular velocity to 0. So if it had any angular velocity, that should be gone. This dot rb dot set gravity scale to, I think that should be 0. Yep. So no gravity is affecting it anymore. That should already be true, but just in case. And then we'll trigger squash me for our state machine, which should tell us to switch animations. We'll say rb.set is sensor. So we should turn into a sensor, so no collision should happen anymore. And then finally, if we want to play the sound, we should say asset pool dot get sound assets slash sounds slash bump dot ogg dot play. All right, so it just does a bunch of different things, which basically just checks to make sure that we have all of these appropriate stuff set. So then if we were to play this, he should switch state machines, and we cannot collide with him if we jump on top of him. And we should do a little, yeah, so we hop on him, and it almost all works correctly. He keeps moving though, so that's wrong. And why does he keep moving? Well, it's because we never checked for if he's dead inside of this function. So his going right resets the velocity and everything. So we should check and see if it's dead inside the update function, so we can handle that. So let's say if he's dead, we'll say time to kill minus equals dt. If time to kill is less than or equal to 0, then this .gameObject.destroy. So we just kill it after 5 seconds, and then we return. So this way we shouldn't reset his velocity, and then his body will disappear because we don't want the carcasses of our enemy on our screen. Okay, so that's almost correct, except he kind of floats away. So we can fix this just by saying this .rb.set velocity to a new vector 2f inside of the isDead function. I'm not sure why we need this. I would have to do more debugging to see what I may have missed that is causing that, but yeah, that should fix it, and we're all good there. Last thing I'm going to do for this episode is implement the player controller's die animation, which is a little bit more involved. So let's go into our player controller, and we'll go ahead and add a new function inside of here. We will just say public void die. We'll say this state machine, first of all, trigger die, which should do the correct animation. And that should basically just downgrade us if we're Big Mario or Fire Mario. And then if we're Small Mario, it should send us to like the actual death animation. So this doesn't actually kill you. It just sort of hurts you. So I guess a better name for this function will be hurt. But we'll say if this player state equals player state dot small. Then we'll say this .velocity.set 0, 0. This .acceleration.set 0, 0. I guess we could just say 0 those. And then this .rb.set velocity, new vector 2f. This .isDead equals true. This .rb.set is sensor. So very similar to what we did for our Goomba just a second ago. We'll say get sound assets slash sounds slash Mario die.ogg.play. So we play the death animation or the death sound. And then we'll say dead max height, which is a variable we'll create in a second, is this.gameObject.transform.position.y plus 0.3f. Because what happens to Mario when he dies? Well, he goes up, then he goes down. So we're basically going to say, okay, go up to this position and then fall back down. And we're going to do all that manually in just a second. Then we'll say this.rb.setBodyType to BodyType.static. So that should stop all physical forces from acting on it. And then we'll say GameObject.transform.position.y is greater than 0. We'll say dead min height equals minus 0.25f. This will just ensure that if we're not already below the screen, we have to go below the screen to end the death animation. Okay, we'll fix all that stuff up in a second. We'll say otherwise if this.playerState equals playerState.big. We'll say this.playerState equals playerState.small. So we'll just switch to a small state. We'll say GameObject.transform.position or .scale. .y equals 0.25f. So we go back to small Mario. Then we'll say pillbox collider pb equals GameObject.getComponent pillbox collider.class. So we basically just have to reset the bounds on this guy. So we'll say if that's not null, jump boost divided by equals the big jump boost factor, walk speed divided by equals the big jump boost factor, which I think we used, and then pb.setHeight 0.31f. So we just sort of reset everything. And then we'll say hurt invincibility time left equals hurt invincibility time, which is like the basic time we get to be invincible for. And we'll initialize all that stuff in just a second too. We'll say otherwise asset pool.getSound, assets/sounds/pipe.ogg.play, which is weird, I know, but that is the sound they play whenever you get hurt in Mario, which I didn't know until this. And then finally, we'll say if player state equals player state dot fire. Then we'll say this dot player state equals player state dot big. Hurt invincibility time left equals hurt invincibility time, which we'll implement in a second. And then asset pool dot set, basically this thing. Okay, so just copy that. It's kind of funny as Mario is in bigger states. The stuff you have to do when he gets hurt is easier, which is weird. It's like the inverse of what he's actually doing. Anyways, with that aside, let's go ahead. We'll say create dead max height, min height, and hurt invincibility time. So if we go up to the top, right before this, we'll just copy that first of all so that we can get that in there. And let's actually change these to floats. So that'll be a float and that will be a float because this is gonna be in seconds. 1.4 seconds is how much invincibility time you get. Then we'll say private transient float dead max height equals 0. Private transient float dead min height equals 0. Private transient boolean dead going up equals true. So the dead going up is basically like, are we moving up in the dead animation, which we'll be using in just a second. And then we'll also have a private transient float blink time equals 0.0f because Mario also blinks when he gets hurt. So we have to make sure we implement all of this. So this is where our player controller just starts getting very complicated. So inside of our player controller, before we do any player checking, we'll say if we're dead, we need to do something else. We'll say if this.gameObject.transform.position.y is less than the dead max height and we are going up, then we want to keep going up. So we'll say this.gameObject.transform.position.y plus equals dt times walk speed over 2.0f, which is just a value I found that worked good. We'll say otherwise if our y position is greater than or equal to dead max height and we're still going up, then we need to start going down. So we'll say dead going up equals false. And then we'll say otherwise if we're not going up and our position.y is greater than the min height, then we need to keep going down. So we'll say this.rb.setBodyType bodyType.kinematic. Not sure why I did that. Maybe I was having problems. Then we'll say this.acceleration.y equals window.getPhysics.getGravity.y times 0.7f. Oh, so we basically just reset it so that we're moving with gravity again, which should be good. And we'll say this.velocity.y plus equals this.acceleration.y times dt. And we'll say this.velocity.y equals, I'm going to grab this because I don't feel like typing all this out once again. It's just going to be this. So copy that, paste it. We're just going to clamp it to terminal velocity. which is good. So clamp it to terminal velocity if we need to. And we'll say this to rb.set velocity to this dot velocity. Set angular velocity to 0. Okay, so that's if we're going down. Otherwise, if we're not going up and our transform position y is less than or equal to the min height, we have finished, we are dead, we're off the screen. We'll say window.change scene to a new level scene initializer. So this should basically just change us back to the original scene and stop the game. We'll see how that works. And then finally return. I want to make sure we return. We also have to deal with if we're hurt and we're invincible for a little bit. So we'll say if hurt invincibility time left is greater than 0, hurt invincibility time left minus equals dt, blink time minus equals dt. If blink time is less than or equal to 0, so we basically want to blink on and off, we'll say blink time equals 0.2f if sprite.getColor. We need the sprite now too, so let's get a hold of that. We'll say private transient sprite render SPR, and then inside start we'll say this.spr equals GameObject.getComponent sprite render.class. So we'll simply change the color so that we look like we're blinking. We'll say sprite.getColor. If the W component is 1, we'll say sprite.setColor. New vector 4f 1110. So we basically just blink Mario off if he's on, and then if he's not, then we'll say else sprite.setColor. New vector for f 1111 instead of 0 for alpha. So you should blink on and off. Otherwise, if we're not blinking anymore and Mario's color.w is 0, we just want to make sure we reset that to 1. So we'll say reset it to 1111. That way he's back to color. Okay, so if we run this, it should work, hopefully. Let's see. If we hit this Goomba, we get the death animation sound, he plays, and then we get the level reset. Cool. So I was not expecting that to work first try, but it did. That's great. Okay, so then if we hit that, we get turned into Hurt Mario, and then we sort of blink there. We should be running through the Goomba, but you know, I'm fine with that. I think that's pretty good for now. So like basically we just blink for a little bit, we're invincible, and technically we should fly through the Goomba, but you know, doesn't matter too much to me. And then once again, if we just hit the Goomba, so I guess it would be easier if I just remove this block. If we just hit the Goomba, we die. Cool. So in the next episode, because this has gone on for a pretty long time, maybe we'll implement the Turtle AI and try and get camera movement working and the camera color working and everything. And we also need to get Z-index working. And I think that should be like almost the rest of the game. The only other big thing that we haven't done is pipes. So, you know, I'll try and get those done too. I hope you guys enjoyed this. If you did, please hit like and subscribe and stay tuned for the next episode. Thanks.